So before I move on here, let's review just a minute, okay? Let's review just a minute, okay? Earlier in this unit, we also had to learn about writing net and complete ionic equations, okay? So I'm going to take a second and do a net and complete ionic equation with this just to remind you, okay? If you can remember how to do it now. If not, watch what I do, okay? If you can predict it for yourself, you're much better off than just watching me do it, all right? But I'm trying to make sure we kind of stay together on this thing, all right? Does anybody remember what you break up in an ionic equation? You break up, well, you don't break up the polyatomic ions, you break the ionic compounds up, okay? So when you write an ionic equation, you break up anything that is both ionic or acidic, it can be either one, and it's aqueous. So this one then, right here, is both ionic and aqueous, and this one is both ionic and aqueous. So those get broken up, but the zinc does not, and the silver does not. Does that make sense? Okay, does it or not? Well, it's just a rule. Anything that's both ionic and aqueous gets broken up. Anything that's both acidic and aqueous gets broken up. You have to know that this is ionic, and that's something we've been going over and over again in the past couple of units. And you know, in this case, you should know this is ionic because we got a polyatomic ion. We said there were two ways to look at a formula and figure out if it's ionic. One way was if the formula contains a polyatomic ion. The other, can anybody tell me what the other way was? Now, we're looking at a formula and trying to figure out is it ionic or not. And you do that by looking, one way is to see if there's a polyatomic ion. If there's a polyatomic ion, it must be ionic. Huh? Not two metals. Metal and a non-metal will tell you it's ionic. Okay? This is stuff that you got to remember. Okay? You got to remember this stuff. All right. If you don't remember that, you should be writing it down again. So you'll try to remember it. Writing it down helps you remember things. So I'm not going to break up the zinc because it's not ionic and aqueous or acidic and aqueous. So I'll put zinc in just the way it is here. But I am going to break up the silver and the nitrate. So silver is going to be Ag, but I need to know what kind of charge to put on it. Where do I find the charge that goes on it? Oxidation number chart. What charge do I put on it? 1 plus, and it is aqueous, so we're going to call the ion aqueous as well. Okay? How many silvers do I have up here? 2 of them, because this 2 outside means I have 2 of everything in there. So there's 2 silvers. Okay? And then we got to put down the nitrate. And what charge do I put on this nitrate ion? 1 negative. Okay, where do you find that? Common ions list. This is aqueous because the compound's aqueous. How many of those nitrates do I have? 2. That's everything on this side. Now I need to write everything on the other side. The silver we don't break up because it's a solid. In order to break it up, it's got to be aqueous, and it's either got to be an ionic compound or an acid. Okay, and this doesn't fit those categories. So we've got 2 silvers we're going to leave in here just like it's written up there. Okay? And then we have to break this one up because it does fit one of those categories. It's an ionic compound and it's aqueous. So we need zinc. Okay? What charge do we put on the zinc? 2 plus. Where do you find that? What's that again? The periodic table with oxidation numbers.
Wait, how come silver is aqueous and not one, but it's solid enough?
Because over here it's part of a compound that's dissolved. It's an ion. This is a silver ion. This is a silver solid. Yes? We're writing a complete ionic equation right now. Okay? How many of these zincs do I have? Just 1. and it's aqueous. Okay? Then we need nitrate. How much is it? How many nitrates do we have? How many? Yeah, it is one negative. How many nitrates do we have? Two of them, and it's aqueous. Okay. All right. That's a complete ionic equation.
So we went, alright, for the second nitrate, and I'm going to hit, we couldn't have did like how we did out there about the parentheses.
No, you don't put the parentheses down here. The only time you put something in the parentheses is when you need two of them in a bond. Okay, or two or more of them in a bond. Since they're not bonded together down here, they've been broken up, they're written separately. Okay? All right, so what do you do to write a net ionic equation? Well, yeah, kind of. That's, huh? Take out the spectator ions, okay? The ones that are exactly the same. Okay? You don't take out anything that's not exactly the same on both sides. Okay, here's a zinc solid. Is there a zinc solid over here? No. There's a zinc ion, but that's not exactly the same. There's a silver ion here. Is there a silver ion over here? No. The silver over here is a solid. It's not the same. Here's two nitrate ions. Are there any nitrate ions on this side? Okay. So do I have exactly the same number? So then I can take out all those nitrates then on both sides. Now, this was a complete ionic equation before I started marking anything out. I'm marking it out to get to the net ionic equation. All I got to do now is rewrite the whole thing without the stuff I take out. Okay? So we got a zinc.
Wait, why would you get rid of it?
Because they're spectators. They're not in the game. Say what now? If they stay the same throughout the equation, you take them out? Is that what you're asking me? Yeah. Yes. Yes, Robert. Yes. Okay? And the value of this net ionic equation is, this is where the action is. This is what's really happening. Nitrates aren't doing anything. They're hanging around watching, aren't they? Okay? They're on the sidelines. They're on the bench. They're in the stands. They're bench warmers. The ones that are actually doing anything are down here. Okay? Well, let's take a look at that sheet. Yeah? Well, this is actually three different problems. Okay? First thing I did was to predict products and balance the equation. Then I also wrote a complete ionic equation. That'd be problem number 2. And a net ionic equation. That could be problem number 3. Okay? All right. Let's look at your lab sheet for a minute.
Wait, that second one's a net ionic equation?
This is a net ionic equation. Let's look at your lab sheet. So what's the first element listed there on that chart? Zinc. Okay. What's the first compound in the second column?
Nitrate.
Zinc nitrate. Does it seem reasonable that zinc will replace zinc in a single replacement reaction? No. They're not going to replace each other. Remember, what's the rule for that? How do you have to have one replace the other? How do you know? Well, it's like it, but it's not higher, is it? It's on the same row. All right? So zinc can't replace itself. Okay? So on your chart here then, your lab prep chart, okay, what are you going to predict if you put zinc and zinc nitrate together in an aqueous solution? Nothing's going to happen? That's your prediction right there. And why not? Here's the explanation. Why not?
Because it's not higher.
Okay, that's a good explanation. It might be something different, and your words might be different than his, but that's a good explanation.
But it's not higher?
That's his explanation. What's yours?
No, like, I agree with what I'm saying.
You're
That's
saying
not
if you
yours.
add another zinc to the Z and
Well, a zinc metal just isn't going to replace itself. It's not more stable. No stability is offered by doing that. That's another way to say it. Okay?
So, like, so the second one is since nitrogen above nitrate.
Zinc is above Ag, so it'll replace Ag, right?
Well, what did we just do here?
Yeah, okay.
Yeah.
And then an explanation because it's higher than actually
Yeah, and actually, I would accept that. A better explanation is that zinc is more active than silver is. Okay?
Where is zinc and
Zinc is right here. Silver's right here.
what number are y'all talking
There's no numbers on this. I'm sorry, I couldn't hear you. What?
Right, what will we write down for prediction?
Your prediction is there's not going to be any reaction here, but there will be a reaction here.
Oh, no.
Yeah.
Oh,
Well, I mean, you know, but you're right. That's true. But you guys have the skills now to figure all these out.
I was looking on that side.
Can you, like, explain it further? There's something more that
I got to that in your brain.
Got it in your brain?
You can have a study group and y'all want to.
Well, there you go. That would be great. You could do it as in a study group. Sure.
Can you just explain
If the metal over here that's by itself in this first column is higher than the metal that's in the formula, or if it's higher than the hydrogen in the acid, it's going to replace it and you're going to have a reaction. If it's not, you're not going to have a reaction. Yes? Will zinc replace copper? What do you think? Okay, why?
Because copper is lower on the...
There you go.
So that's all you're
Yeah.
So you just say zinc will replace? Or, like, is that pretty much the only name?
Your prediction is there will be a reaction. Your explanation, or there won't be a reaction. Your explanation is why you think that's the case.
Or there will be a reaction and why?
Yeah. Okay? All right, now, we're not going to finish this right now in class. We're going to put this away. But before we put it away, let me go back again and explain one more time what I said earlier about what goes in your lab notebook. This does not go in your lab notebook. This sheet you're going to have finished before you come to class tomorrow, and you give it to me before you go to lab. What you're going to do in your lab notebook is prepare a similar chart to put your results from the lab. Okay? So you're going to have a chart that looks much like this in your lab notebook, but instead of having a prediction and explanation column, you're going to have an observation and an explanation column. And this explanation is if what you actually saw was different from your prediction, that's what you want to write down here.